In this video, we're going to talk about transformations of different types of functions. A transformation is a change from the original to something new. Think of it as of pizza. For example, you prefer just straight pepperoni pizza with nothing on it, and your friend prefers pizza with multiple toppings. You still start with that pepperoni pizza, right? And then you transform it by adding a variety of toppings to it. So the pepperoni pizza is the base function, like y equals x squared, or y equals square root of x, or y equals 2 to the power of x. All of those are basic equations of the main types of functions. We can transform them. We can add those toppings to them. Let's see how. Here are the toppings that were being offered, the transformations that we could have applied to our function. Reflection in the x-axis, reflection in the y-axis, vertical stretch by a factor of 2, vertical compression by a factor of 2, horizontal shift to the right 2, horizontal shift to the left 2, vertical shift up 1 or vertical shift down 1. Each one of those transformations correspond to a specific topping on the pizza, and we're going to see what our particular pizza has and try to express it as the transformed equation of the quadratic function. If we had all possible toppings on our pizza, then the corresponding transformed equation of a quadratic function would look like this. A is responsible for the reflection over the x-axis and vertical stretch or compression. H is responsible for the horizontal shift to the left or to the right. And if you see negative inside the bracket, it means move to the right. If you see positive inside the bracket, move to the left. K determines the vertical shift, up or down. So here, if K is positive, move up. If it's negative, move down. Here is the pizza and the toppings on it. Let's determine what we have here. We have a reflection in the x-axis, we also have horizontal shift right 2. And in addition to that, we have a vertical shift 1 down. Let's apply those transformations to the function that we have. So then f of x is equal to, the a value is responsible for reflection in the x-axis. If a represents the reflection in the x-axis, it should be negative. And since there is no change to a in terms of stretch or compression, it always remains as 1. So a is negative 1. X stays as a variable because it represents every independent value of any point on the parabola. Next, we have a horizontal shift right 2. Horizontal shift is h, and if we move to the right, the value inside the bracket is negative, x minus 2 squared. Vertical shift 1 down. So if k is negative, then the parabola is being shifted down. Subtract 1. So this is a transformed equation of our parabola. F of x equals negative x minus 2 squared minus 1. Let's see what the graph of this parabola looks like. So the following is the graph of this parabola that we have transformed. The reflection in the x-axis, the vertex of the parabola is at positive 2, negative 1, or the parabola has been shifted 2 to the right and 1 down. Now let's look at a square root function, and here are the toppings that we can choose from. Reflection in the x-axis, reflection in the y-axis, vertical stretch by a factor of 2 or vertical compression by a factor of 2, horizontal stretch by a factor of 1/2 or horizontal compression by a factor of 1/2, horizontal shift 1 to the right or horizontal shift 1 to the left. There is no vertical shift up or down. Let's see what the transformed square root function might look like in general and what transformations we need to apply to get the pizza that we want. So here is a general form for the transformed square root function. A represents the value that is responsible for reflection in the x-axis as well as vertical stretch or compression. K is responsible for the reflection in the y-axis as well as horizontal stretch or compression. D is a horizontal shift to the right or to the left. And if you see a negative inside the bracket, it moves to the right. If you see a positive, it moves to the left. C is a vertical shift, up or down. If it's positive, move up. If it's negative, move down. And here are the toppings that we want on our new pizza, which is a square root function. We have a horizontal compression by a factor of 1/2. What else do we have? And we have a horizontal shift one to the right. That's it. Let's try to apply these transformations. So f of x equals, make sure you make no mistake here because the pizza has to be exactly as ordered. So A, there is no vertical stretch or compression, and there is no reflection in the x-axis. So A remains as positive 1. Now the k value. K value is the reflection in the y-axis, which we don't have, but it's also either horizontal compression or horizontal stretch. We have a horizontal compression by a factor of 1/2. The original k value is 1. Since the original k value is 1, and now we have a horizontal compression by a factor of 1/2, the k value needs to be the opposite of what we see and what we're given. So the k value will not be 1/2, it will be 2. Next, what else do we have? We have a horizontal shift 1 to the right. X, horizontal shift is D. And if we see 1 to the right, we keep it negative inside the bracket, so -1. And C is a vertical shift up or down, and we don't have any, so it's just going to stay as 0. There is no vertical shift whatsoever. So this will be the final equation of our transformed function. Square root of 2x minus 1 under the root. Let's see what the graph of such function looks like. It usually helps to graph the original function first and then the transformed function. So in this case, I'm going to show you how. See, the green function is the regular g of x equals square root of x. It's the base graph of the function before it was transformed. This is our pizza with just the pepperoni on it. And the purple graph is the transformed graph. This is the pizza with the toppings that we have applied. So we have a horizontal shift, 1 to the right, and we have a horizontal compression. So the function is horizontally compressed or vertically stretched. It's a little steeper than the green one. And this is the transformed version of the original function.